Hello everyone, welcome to today's math class. Today we have this challenge before us here. If you check carefully, I released a video on this same challenge not quite long, and I promised in that video to still use two different approaches, two different methods in solving this same challenge. The reason of using three different methods is for you to pick the one you feel best, that is best in case of examination. Okay, so in this method, I want to use the binomial expansion. If you've not watched the first one, then I'm going to drop a link in this very video where you gain access to the first one I've already released. So the question is, bracket open, the square root of 3 plus the square root of 39 all over the square root of 12 all raised to power 7. So like I said, we want to use the binomial expansion here. But before that, we have to reduce this to the simplest form. Because I've done that in the previous video, I'm not going to waste much time reducing this. So I'm going to go straight to the simplest form or format of after reducing this. So, but before that, let's take our solution. So let's take our solution to this problem. Okay. So we know that our bracket open the square root of 3 plus the square root of 39, okay, all over square root of 12, all raised to the power of 7. When simplify, we give us our bracket 1 all over 2, the plus the square root of our 13 all over 2, all raised to power 7. So this is not a problem, right? Good. So how do we now handle this without the use of the calculator? This is where this second approach comes in. So in the first approach, I have to break this down to 2 times 3 plus 1. Okay, but here we're going to use the binomial expansion. So from here, using the binomial expansion, so using the binomial expansion, binomial expansion. Now, if we have our expression bracket open x plus our y all raised to the power of 7, then this will give us our x all raised to the power of 7, which is the first term, and this first term has a coefficient of 1. As a matter of fact, we are to apply the uh, Pascal diagram to get the coefficient of each of the terms. And look at the Pascal diagram. Here is the Pascal diagram from the power of 0 till the power of 7. And so we are considering this part here. So this is the coefficient to the first term, second term, third term, fourth term, fifth term, sixth term, seventh term, and the eighth term. So we are going to make use of this coefficient here in simplifying our expression. And so from here, we're going to have the first term will be the only one that will exist. Then we have here plus the second term is going to be 7, which is the coefficient. The x will now reduce to our 6, and our y will come into the system. Then plus the next coefficient is 21. There times our x will reduce to 5. Meanwhile, our y will increase to 2. There plus the next coefficient is our 35 rather. So we're going to have 35 x to the power of 4, y to the power of 3, then plus the next coefficient is still going to give us 35. So we have 35, the x to the power of 3, the y to the power of 4, then plus the next coefficient is going to give us 21, then x to the power of 2, y to the power of 5, and the next coefficient is 7, x to the power of 1, then y to the power of 6, and the last one, the coefficient is just 1, and it will be just y to the power of 7. All right, so this is the expression we're going to make use of, okay, according to binomial expansion. All right, so how do we now express this expression we have here now in this format. It is very easy. So let's bring down our expression. So we have bracket open our 1 all over 2, the plus the square root of 13 all over 2 all raised to the power of 7. Let's write this very well. Now, we're going to take our x to be 1 all over 2, and our y is root 13 all over 2. So this is going to give us, so let's take it gradually. If we take this gradually, we're going to have the first term is going to give us our 1 all over 2 all raised to the power of 7, then plus the second term will give us our 1 7 as the coefficient, then times our 1 all over 2 all raised to the power of 6, then times our square root of 13 all over 2 close bracket, then plus the next one will give us the coefficient of 21, then times our 1 all over 2, then all raised to the power of our 5, then times bracket open the square root of 13 all over 2, all raised to the power of 2. Then the next one will give us plus the coefficient is 35, then bracket open 1 all over 2 all raised to the power of 4, then times our square root of 13 all over 2 all raised to the power of 3, then plus the next term will give us our 35 again, which is the coefficient is still 30, 5, then bracket open our 1 all over 2 all raised to the power of 3, then times, sorry, here we have times our square root of 13 all over 2 all raised to the power of 4, then plus the next term will give us our 21. We have 21 into 1 all over 2 all raised to the power of 2 into the square root of 13 all over 2 all raised to the power of 5. Then the next one will give us our 7 as the coefficient into 1 all over 2 all raised to the power of 1, then times our square root of 13 all over 2 all raised to the power of 6, and the next one, the coefficient is going to give us just 1, then 1 all over 2 will leave the system, so we're going to have our square root of 13 all over 2 all raised to the power of our 7. Wow, this is wonderful, right? Good. I refer to this method as the crude method of solving this challenge. But let's see, after the first, second, and third, we can compare and actually pick the word that is the crude method. But to me, this is the crude method. All right, so this will now give us equal to, if we are to simplify this, 1 all over 2 all raised to the power of 7. This will give us 1, and 2 times 2 times 2 times 2 into 7 places automatically will give us 128. So we're going to have the first term here, 1 all over 128. That is the answer for the first one. Then the second one, which is this, we're going to raise this to the power of 6, whatever to have the times 7 times this expression. So the top will give us here our 7 root 13, then all over. If we raise this to the power of 6, the times our 2 will give us 128 also. The plus, we go to the next one, which is 21 times everything we have here. Then if you multiply everything out here, because this will cancel out this root here, and so if you multiply everything out here, this is going to give you 273 all over 128. The plus, we come to the next one, which is this very term here, having 35 as coefficient. So if we simplify everything, multiply everything out here, this is going to give us 4 5 4 5 5 root 5, sorry, root 13, then all over our 128. Then plus, again, we come to the next one, which is this. If we simplify everything here, then this is going to give us our 5,915 all over 128. Then let's go gradually. The plus, we now have the next term, which is this 21. So for the term of 21, we're going to have our 3,549 root 13 all over 128. Wow. The plus the next term, which is this. If we open up everything here, this is going to give us our 1,579 all over our 15,379 all over 128. Then plus the last one, if we open up everything here, this will give us 2197 root 13 all over 128. Okay, so let's go ahead and add the terms that are not having root together. So we can add this to this, to this, and they will give us something reasonable. But if we add this, or let's bring that together first. So we're going to have the first one, which is our 1 all over 128. The plus, the next one we have 273 all over 128. The plus, this we have 5915 all over 128. Then plus, next one we have our 15379 all over 128. The plus, let's take the one having root here. So we have 7 root 13 all over 128 plus the next one having root is 455 root 13 all over our 128. Then plus next one having root is 3549 root 13 all over 128. Then plus the last one, which is 2197 root 13 all over 128. So at this point, let's go ahead and add up everything here. You discover that these are having the same denominator. So this now implies, or this is equal to, so we have a common denominator, which is 128. So if we add 1 to 273 to 5915 to 15379, everything will give us our 21568. Then plus, then we take these together. If we add, because they're also having the same denominator, right? Okay, so let's drop our denominator. We have 128. So if we add up 7 root 13 to 455 root 13 to this and to this will give us our 6208 root our 13. Okay. So we discovered that 64 can divide this and 64 can equally divide this. So if we use 64 to divide this, 64 here, we're going to have our 2 here, and 64 here is going to give us our 3, 3, 7. Then again, we can equally use 64 to divide this. 64 here will give us 2. 64 here, we discover we have 97. So rewriting this, we're going to have our 337 all over 2. The plus, here we have 97 root 13 all over 2. So if we are to rewrite this expression could be written as our 1 all over 2, because nothing can divide this and nothing can divide this without remainder. So we have 1 all over 2. into our 337 there plus 97 root our 13. Okay, so in all, if we are to bring our original equation, so it all means this now implies that our bracket open the square root of 3 all over, okay, let's say plus our root 39, okay, all over root 12, all raised to the power of 7. When simplified, will give us our 1 all over 2 into our 37 there plus 97 root 13. Now, if you watch the first video, you'll discover that this is the answer we also got from solving this same challenge using the first method. If you are not clear with any of the steps applied in solving this, then also drop it in the comment section. Between the first and the second approach applied in solving this math challenge, drop in the comment section which you prefer. I will drop the third method so that we can have a clue of the three methods and draw our comparison. Thank you for watching Online Maths TV. See you in our next class. Till then, keep winning.